hill climbing algorithm works in a loop which moves towards the goal state one at a time. However, the main drawback of this algorithm is if it hits the maximum local value, then it assumes that there is no better results than the current state. So it terminates the calculation. So that's what we are going to see, and success to failure ratio we are going to see during this implementation. So for this implementation, we have imported all the required libraries and created functions to perform all the different tasks. So this implementation, let's start with the implementation, and with each of the function. This function set disk that will give us the result of how many queens we have for a given row. It will be calculated, and then the next function we have a uh, state here state heuristic function, which will give us the heuristic value of this state, and like it will give us the value number of pairs, how many queens that are attacking each other. So it to reach our final goal state, it should be 0. So no queens are attacking each other. So that should be our goal. And the another function we have here, it is get random steepest ascent, which will return the state with the lowest heuristic value among the successors, which are the neighbor states. The print page and get move function uh, will give the track of each move from the current state to the given neighbor state, and moreover it returns the count of moves it has taken to reach the final state, whatever in state we are currently we are. The hill climbing steepest extent function uh, is the exactly the function which put all the other functions together and give us the final results, and it will provide us with the exact output that algorithm has succeeded or stuck to the local minimum value. For the calculation of failure and success counts, we have integrated fail count and success count variables, which will give us the count of successful solutions and failed solutions out of 1,000 times we have run the calculation. And the final function get random checker page function, it will give us the board of our desired dimensions. Let's say for example we want to create the board for 8 queens problem, then it will generate the board with eight queens on board randomly with 8 by 8 size of board. So that's what that function do. And the finally we have a for loop, which will put all these function together and run the algorithm for 1,000 times, and give us the results, how many times it has succeeded and how many times it failed, and what are the values of success move and failed move. So let's execute it all together. So here it is for 10 times. Let's change it for 1,000, and it is executing. We can see here out of 1,000 times, it failed for 873 times and it succeeded for 127 times. So it is almost similar to whatever we have seen in our textbook and whatever we have discussed already. It's almost 86% to 14% success to failure ratio, failure to success ratio. The same thing we have performed for 10 queens problem as well, and just we need to mention the value 10 here in board, and we will perform the task for 1,000 times as well. and the same thing we have performed for other problems with 15 queens or 16 queens on board to check the uh, limit of the system, how up to which system can take and at what complex problem system exhausts. So that is all we have in this problem. That's it. Thank you.